Today, we're going to look at going back to your little flip book for circles, and we are going down to where it says properties of tangents. Okay, so we need to flip over to where we see properties of tangent, and this is what you should see. Okay, since we've been talking about tangents and we've been talking about that point of tangency and everything, we have a few things that we will go over. There's really about 3 things about the tangents that are very important for us to work with. Okay? One of those is if you have a tangent that has been intersected by a tangent line and a radius, and they intersect at that point of tangency, okay, that means that this is a true tangent because I am going to be perpendicular. Okay, and remember, perpendicular means that you have a right angle right there where that radius and that tangent line intersect. Okay, so that's the first rule. So we may have to use that Pythagorean theorem to be able to either show I have a tangent line or to find a missing length for that. Then we had congruent tangents. Okay, the main thing about those is you have 2 tangents that intersect outside. So you've got this tangent of AB and this tangent of CB. They are intersecting at point B. So these 2 things, the length of A to B and the length of C to B, are going to be equal in length. Okay? That's the second thing that we need to look for when we know that we've got some tangents. The third one is when you've got a circle that is inside of a triangle. Okay. If you will notice and really think about it, you have a lot of little tangent lines. Okay. You have this little tangent right here and this one right here. So those 2 little tangents right there would be congruent in length, because it's kind of like this little picture over here. It's using this rule right here, just a lot more of them. Then we have this little tangent right here and this tangent right there. So those 2 things would be congruent. Then we have one more set of tangents. This tangent with this tangent would be congruent. So as long as I know one, or I know a whole length to where I can get one, then I can pop that answer around a lot and be able to find that missing piece. Okay? So let's practice 1, picking out the rule we need, and 2, figuring out how we're going to solve for it. Okay, so on example 16 right here, or problem 16, it says find the value of x. Well, this right here is that tangent line, okay, being intersected by your radius. Now, here's the thing. The only length I know, the way they've put it on here, is from outside the circle to this point right here. That's a length of 8. Well, we already know from here out to our circle, because that is just a radius. My radius here was 9, so I get to jump a 9 right there. Then I need the whole length. So I'm going to add my 9 plus 8 and get my 17. Okay, so now then I need to be able to use that Pythagorean theorem. That a squared plus your b squared is equal to your c squared. Okay, so I should have a right angle right there. So that means that 17 is that c. It's across from the right angle, and it's also the longest side that I have. So that means that 9 and x are my 2 legs. So 9 squared plus my x squared. So then I'm going to go through and do the math. 9 squared is 81 plus my x squared. See, 17 squared is 289. Then I'll subtract my 81 from both sides. So that's going to leave me with x squared being 208. Then I'm going to square root that. So my x would be roughly 14.4. in my length. Okay, now let's go to number 17. Once again, he's kind of like this one, but the thing we need to do is to watch for those radius. This radius is 8, so how long would this radius be? He would also be 8. So then this whole length right here is going to be 16. So again, this is a tangent line being intersected by a diameter or a radius. So your right angle should be right here where they're intersecting at. It's always where those two things intersect at. And so we're going to use Pythagorean's theorem again. A squared plus b squared is equal to c squared. So it looks like across from the right angle is my x. So that's going to be that c. So that's going to become my x squared. So that means that 16 and 13 are my two legs. So 16 squared is 256. 13 squared is 169. And that's equal to my x squared. So we're going to add our 256 and our 169. And we're going to get 425 is equal to x squared. Take your square root of that. And so my x is going to be approximately 20.6. Okay, now then, let's look at number 18. When I look at 18, we're going to skip 18 because on 18, it's going to be asking me to do more than I'm really going to do with you. So we're going to skip question 18. And we're saying, let's look at 19. Find the value of x. Okay, so on this one, if this length is x, this length is x. So the whole length right there is going to be x plus x, which is a 2x. And then I need this whole length right here, 12 plus 5 is 17. So again, I'm going to that a squared plus b squared is equal to c squared. And let's think about, that's my longest side. Your right angle should be right here. It's always at that point of tangency. So c squared is going to become 17 squared. Then I've got an 8 and a 2x. So I get a 2x squared and an 8 squared. When you have a 2x squared, you're going to square each number. So 2 squared is 4. X squared becomes that x squared. Plus 64 is equal to, I believe that's 289. Yep. Subtract your 64 from both sides. So that's going to give me 4x squared is equal to 225. So I've got to divide by 4. So I'm going to get x squared is equal to 56.25, then square root both sides. So your x is going to equal to 7.5. Okay. On number 20, 20 we are also going to skip because it's going to involve more than what we're going to do. If you was with me, we might, but since you're not with me, then we're going to skip these two. And we're going to go 21. Now in 21, you have two tangents and they're intersecting outside of that circle. So we're going to be using this rule right here. Outside my circle, what do I know about the length of AB and CB? They are equal. Okay, so all I've got to do is come down here and say, well, this side of 8x minus 39 is equal to 3x plus 16. And then just solve this. So I'm going to subtract 3x's from both sides. So that's going to leave me with 5x minus 39 equaling to 16. Then I'm going to add 39 to both sides. So 5x is going to equal to 15, 3, 4, 5, 55. And then divide by 5. So x is going to equal to 11. And you can plug that back in on this side and make sure they do equal. Okay. Then on this one, I want to find the perimeter of the triangle JKL. Well, that means we're going to be doing this one, where I've got a lot of little tangents that are equal to each other. Okay? So the first thing that I want to start with is I want to start with this little piece right here. Them two little tangents right there. That's what I'm going to start with. So the first thing I'm going to do is I'm going to set them equal. 4x plus 15 is equal to 15x minus 7. I will add my 7 to both sides. 4x plus 22 is equal to 15x. Subtract my 4x. So 22 is going to equal to 11x. Divide by 11. X is going to equal to 2. So here's what I want to do. I want to plug in 2 right here. 15 times 2 is 30. 30 minus 7, I know that length right there is 23. Then I've got 4 times 2 is 8. 8 plus 15 is 23. So I know this length right there is 23. So I got 2 things out of my way. Okay. Then we also have this. We've got this little tangent right here to this little tangent right there that are going to be equal. Notice I marked them in the same color, so they're equal. So if this is 7, what's KDM going to be? He's also going to be 7. Then the last one is this little tangent and this little tangent. Well, here's the thing. You know this whole length right here is 26, but we're using 7 of it. So in order to get J to M, we're going to take 26 minus 7 to give us 19. Okay, so they didn't give me the whole something that I can just bounce around down here with this yellow, but they did give me the whole length of your side. And when they give me the whole length of my side, As long as I know what one little piece is, all I got to do is subtract. So if that's 19, then what's this little J2P going to be? He will also be 19. So now to get the perimeter of my triangle, that just means I'm going to add up all sides. 7 and 7, 19 and 19, and 23 and 23. Okay, so I got 7 plus 7 plus 19 plus 19 plus 23 plus 23. So my whole perimeter of my triangle is going to be 98. So this looks like it's going to be something very difficult, but it's not, as long as I've got little pieces of tangents that are intersecting other little tangents. Then I can just pop numbers around that are the same. Might have to do a little subtraction, might have to do a little solving for x. Okay. But I can be able to jump those things around knowing that I got a bunch of tangents and be able to solve for what I am looking for. So that's our lesson today. We're looking at those tangents. We're either jumping things around, setting things equal, or using Pythagorean's theorem to be able to solve. Please watch how they label their pictures, though. I may have to jump a radius to the other side and add up for the whole entire length. So just be careful.